Hello students, I am Mr. Adinath D. Badar, Assistant Professor, Department of Chemistry, Late Pushpadevi Patil, Arts and Science College, Risod, Dist, Washim. In the previous video lecture number 1, we will see the basic of periodic tables and atomic radii, its types and variations. Now today in this video lecture number 2, we will see unit first topic, that is ionization energy. So firstly we see the contents of today's lecture, that is ionization energy, its types and variations, and effects of ionization energy on various properties of elements, that is metallic and non-metallic characters, oxidizing, reducing power, then acidic and basic nature, and reactivity of elements. So firstly we see the definition of ionization energy. See, the ionization energy is the amount of energy required to remove the outermost or valence shell electron of an gaseous isolated atom to from a cation. This is energy required process and hence it is called an endothermic process. It is represented by ionization IE or IP. IE means ionization energy and IP means ionization potential. It is also called as ionization potential or ionization enthalpies. So this diagram shows these are the valence shell electron, these are the nucleus, and these are the inner shell electron. So energy needed to ionize or to remove the valence shell electron, that is this electron, is called as ionization energy. In another, the ionization potential is the energy needed to the remove of an electron from an isolated atom or molecule. For example, these are the atom, these are the nucleus, and these are the surrounding or inner shell electron, and these are the valence shell electron. So the amount of solar radiation or another radiation required to ionize or to remove the valence shell electron is called as ionization energy. So these are the general reaction Xg gaseous state atom plus amount of energy to give cation plus free electron, and this is called as first ionization energy. The above this process is specially called as first ionization energy, and similarly corresponding to the removal of second electron, removal of third electron, removal of fourth electron, it is called second ionization energy, third ionization energy, fourth ionization energy. Here the electron are removed from monocation, that is the second electron from cation, second electron from monocation. Then this process is called as second ionization energy. Here the electrons are removed from dication, that is the number 3 electron. Then it is called as third ionization energy. Here the electrons are removed from trication, that is fourth number electron. Then it is called as fourth ionization energy, and it is denoted by I1, I2, I3, I4. The increasing order of for ionization energy is always fourth ionization energy is greater than third, third is greater than second, and second ionization energy is greater than first ionization energy. Now we will see a periodic variations of ionization energy or trends, means what happened from left to right and top to bottom. So firstly we see in a period or along a period, that is left to right, ionization energy in generally increasing from left to right with increasing atomic number. This can be explained by taking a consideration as follow. We know that atomic size goes on decreasing from left to right in a period. It means that the distance between nucleus and outermost cell electron is decreasing from left to right, left to right. Now, the positive charge or nuclear charge is increasing regularly due to the increase in atomic number. This electron is attracted much more strongly by the nucleus and hence its removal becomes increasingly difficult, due to which more and more amount of energy will be needed for the removal of outermost cell electron. To overcome this increasing attractive force between it and the nucleus, therefore, the ionization energy goes on increasing from left to right, goes on increasing from left to right due to decrease in atomic radii. The nucleus and valence shell electron attracted much more strongly to that of lithium. Here the now there are some exception to this general trend in second period and third period. Here the ionization energy is increases from lithium to neon in second period, and here sodium to argon increases, but in beryllium in second period beryllium and nitrogen shows higher value and neon also shows higher value. This is due to full filled and half filled stability of orbital. In third group, the magnesium and phosphorus and argon shows higher value. This is also due to full filled and half filled orbital stability. Now, in a group that is top to bottom, generally the ionization energy goes on decreasing with increasing atomic number in a group or top to bottom. This decreases in the values of ionization energy can be explained by taking a consideration of mainly three factors. Firstly, here the ionization energy generally increases from left to right and decreases from top to bottom. Here top to bottom example, that is this one is alkaline earth elements from magnesium to radium. The ionization energy is decreases like alkali metals. Here sodium to francium, the ionization energy is decreases. These are the general trend, means top to bottom ionization energy is decreases with increase in atomic number. Now we will see why the ionization energy decreases from top to bottom, which factors are affect on. So firstly we see increase in atomic size. These are the reason for increasing decreasing ionization energy, that is increases in atomic size. Moving down the group, the atomic size goes on increasing continuously. Due to this, the outermost electron experience lesser and lesser force of attraction towards the nucleus. This decreased nuclear attraction makes the removal of outermost electron more easy, thereby requiring lesser and lesser amount of energy, and hence the ionization energy is decreases from top to bottom. Here these are the nucleus that is having positive charge, and these are the valence shell electron. We know each every movement along a group, cell is added, that is here number of cell is 2, here number of cell is 3, here number of cell is 4, means the valence shell electron goes away to the nucleus. As a result, laser attraction between valence shell and nucleus, so the electron easily remove if the size is increases. So along a group, the ionization energy is decreases due to atomic radius is increasing. Here we see the example, first group, that is alkali metal group, that is hydrogen to cesium. Here hydrogens have a ionization energy is 13.59 as compare cesium shows 3.89. These are the top to bottom. Also we see left to right. Left to right, we know the ionization energy decreases. So this group, lithium shows 5.39 and neon shows 21.58, means ionization energy is decreases from top to bottom and increases from left to right. Now the second factor is screening effect. So firstly we see the definition of the screening effect. It is also called as shielding effect of the inner electron on the outermost shell electron. So firstly we see the definition of screening effect. The repulsion occurs by the valence shell electrons due to the presence of inner shell electron is called screening effect. More the number of cells, stronger is the increasing or screening effect, since every time there is addition of new cell, this effect becomes more and more stronger and contributes to the increase in repulsive force between nucleus and outermost shell electron, hence laser attraction between them. Here this diagram shows these are the valence shell electron carries negative charge and inner shell electron also carries negative charge. Due to electron always carry negative charge and this nucleus carry positive charge, so these negative repel each other. As a result, laser the attraction between this negative charge and this nucleus. You know what is repulsion? That is negative charge versus negative charge always repel each other. Same positive versus positive repel always every time, but the positive and negative charge attracted each other. So now here this diagram clearly shows these are the valence shell electron, these are the inner shell electron, and these are the nucleus. Nucleus carry positive charge, this inner shell electron is negative, these outer shell electron are also negative. So these negative repel each other, but the nucleus and this negative charge, that is positive and negative charge, attract each other, and this is called as attraction and this is called as repulsion. So this effect is called as screening effect, and screening effect goes on increasing from top to bottom. As a result, ionization energy is decreases from top to bottom. Now next, the third factor is increasing atomic number, that is effective nuclear charge. That is nothing but the effective nuclear charge. We know as we move from top to bottom, the atomic number goes on increasing. As a result, the effective nuclear charge is also increases. As a result, the ionization energy is decreases. The detail of effective nuclear charge we will see in next lecture. What is effective nuclear charge, how to calculate, it, and some problems on effect calculation of effective nuclear charge will be seen in a next lecture. Now the third factor is increase in atomic number. Now the next topic is effect of ionization energy on different properties of elements. So first property is metallic and non-metallic characters. So firstly we see what is a metallic character. So as an elements having ability or metals to lose one or more electron to from cation. This ability to loss of electron depends upon the ionization energy. With increasing ionization energy, the metallic character is decreases. When we move from left to right in a period, ionization energy is increases, which is turn decreases a metallic character. Hence, alkali metal, alkali metal, hence alkali metal always show metallic in nature, whereas the halogen family, that is p block elements, always shows non-metallic character. The next property is relative reactivity of elements, that is the reactivity of elements. The elements with higher values of ionization energy are less reactive. For example, inert gases, that is this side gases, or last group gases or 18th group elements are less reactive due to high value of ionization energy. Then elements with lower values of ionization energy are more reactive. For example, alkali and alkaline earth metals, that is S block elements, shows high reactivity due to low values of ionization energy. They are easily lost electron and react to other elements. As compare, the p block element can't lose easily electron and do not react fastly. Now the fourth property is oxidizing and reducing properties. And elements which reduce other elements itself undergoes oxidation, that is losses of electron by supplying electrons, and is called reducing agent. This ability of elements to reduce other is called reducing power of elements. It is depends upon the magnitude of ionization energy of an element. Lower the ionization energy of elements, greater the ease of its oxidation and stronger the reducing agent. Therefore, alkali metals having lower ionization energy values are stronger reducing agent. On the other hand, halogens with higher values of ionization energy are stronger oxidizing agent. Here this diagram shows these are the reducing agent. Loss electron or supply electron A to B, and B gain electron, B gets reduced and A gets oxidized. This is called as reducing agent. Those elements which supply electron are called reducing agent, and those elements which accept electron, it is called as oxidizing agent. This is vice versa procedure. Now the next and last effect is acidic and basic nature of oxide. Acidic and basic nature of oxide, an element which loses an electron easily and gets converted into positively charged ion or cation, is said to show more basic characters. Lower the values of ionization energy, easy to remove of an electron, therefore lower the values of ionization energy of an element, greater will be the basic character. Metal oxide and hydroxide are basic in nature. They easily ionize to give metal cation. For example, these are the calcium oxide plus water. The calcium hydroxide is intermediate to gives calcium plus 2 plus hydroxide ion. Here the sodium hydroxide is ionized to gives Na plus plus OH negative, that is sodium cation plus hydroxide ion. So the acidic and basic nature of oxide is depends on ionization energy.